Mhm. Where the hell's the pen? There it is. Okay, let's get started. So anyway, first of all, great job on the exam. I was very pleased. I know most of you did your part, your 40%. And based on the results, I did my 40%. And then I guess the ones who didn't do too well, I guess they didn't have the 20%, right? So now the average, I think, of the median was around a 67, which I was pleased because in physics, what is it? Usually like a 47 or something. Anybody take a much lower? Sorry, 38. I'm just kidding. It wasn't. No, we were most of everybody was a B plus. So that was so great job. All right, half the class got at least a B plus. There were a couple of questions. It was obvious is either the ones, this would be 47% of the class. It was obvious they didn't come to class or they didn't watch the lectures. And one of them was, about reasons why people are vegetarian, right? So one of the questions was, why is it that Dr. Mobley chose to be a semi-vegetarian? You guys remember that question? So what's the answer? Bonded with cows and pigs. Come on, how can you miss that question? It's so silly, right? So, but for some reason, out of 250 students, 47% got it wrong. So you tell me what it means, right? So I don't know. Maybe it's a bad luck. The other one was the other one that I was hoping that everyone should have gotten was about fish oil supplements. Remember, let's clarify that with fish oil supplements, we do not recommend it. We do not recommend it to prevent heart disease. Now, if you already have heart disease, yes, we would recommend it, right? But we don't recommend it to the general public to prevent heart disease, okay? Because the risk do not outweigh the benefits. And I guess those were the only two that I was hoping everybody would have gotten in terms of concepts. So it'll probably show up on the final. So that's all I'm saying. All right, so anyway, the class overall is doing great. You guys have been a great team. So just keep it up. Don't slack off. If you slack off, I promise you, or maybe that one exam bites you and the gluteus maximus. So again, so don't do it. Just keep doing what you're doing, right? Now remember, what you're learning in here is the most important class you'll ever take at UF, right? Because again, you're learning about yourself, and you're going to be also in terms of these health recommendations. Of course, that may be one of your patients, your family members, or whomever. And that's one of the things we're going to be talking about today is a heart disease, because half of us, that's how we're going to end our life, is having from some type of event related to either a stroke or a heart attack. And it's the #1 cause of death throughout the world. And that's what we're going to be talking about when we talk about lipids and health. All right. All right. So let's get going. Did everybody have a great spring break? Yep. A lot of refreshments that contain fat. Don't forget about the extra credit. And I got one because some of you already turned it in. And I mean, they're hilarious. I'll share them with you at the end of the week. So again, we got to keep up the morale. Okay. So in terms of our lipids, first of all, our lipids, we're talking about fat, of course. So of course, when we talk about lipids, we're primarily talking about those foods such as meat, fish, and poultry have a lot of lipids. Also, anything comes from animal sources. And then also we have plant sources of lipids. And we've already talked about this, such as nuts, for example. Then some, and as well as coconut as another example of something that contains a lot of lipids, avocado, and so forth. So as you recall, when we consume dietary fats, most of these fats are going to be triglycerides. We're going to first emulsify it. So we've already learned about this. Once we emulsify it, then that's when the pancreatic lipase is going to break it down to 3 fatty acids. Going to get into the enterocyte, get reassembled, and then packaged into a kilomicron, right? And remember, from the exam, kilomicrons is what's carrying fat from your diet throughout your body. And that's what we're going to talk about now today, is what happens to that fat once it gets our body, right? And of course, most of it's going to be absorbed in the intestines, in the jejunum. So one of the primary sites, what's going to happen to those triglycerides, and we're going to take a look at the chemistry in a second, but they're going to end up getting stored in your fat tissue. Now, your fat tissue, we'll talk about some of these, is very important. This is our long-term energy storage. Also, our fat tissue is very important for insulation. So, for example, it's important for our nerves, and we're going to talk about this. It's just an overview. And it's also very important to keep you warm. So if you think about polar bears, right, up in the Arctics, they have so much percentage of body fat. It's like 70% body fat. And they need that fat, first of all, for energy, right? So when they go long periods of time without eating, they have a source of that energy, but also it keeps them warm. So, and oftentimes you may see polar bears, they get too warm in the summer and they're laying out on the ice. Cutest thing, but if you walk up to a polar bear, you might not be coming back. They're very dangerous. All right, so anyway, that's an example of the insulation, right? And also protection. The fat tissues, they protect your bones. For example, in the elderly, we much prefer, you've heard the term cushion for your tuition. You heard that before? Cushion for the tuition, right here. Well, that's talking about here. But anyway, the fat here, your cushion, anyway, the fat in this area here, it's protecting your hip bones. So whenever someone is old and frail, of course, some of that fat is missing, and they're much more likely to have a hip fracture. So one of the things that the fat does, it helps protect you. So when you fall, it absorbs it, right? All right. So, and then also fats, they are going to be our primary energy source. For every gram of fat, there's 9 calories. And then in turn, of course, our muscles, they love glucose, but they really love fats. This is especially true for fatty acids in terms of racehorses. So if you know anything about racehorses, they feed horses a lot of fat because of the primary energy substrate. It's going to be those fatty acids. Okay. And then, and then we also are going to use it for our membranes, eicosanoids. And like, again, we're going to go a little bit more in detail in all of these. This is just more of an overview, all right? All right, so, so one of the first functions of fat is going to be satiety. Now, what satiety means, this means feeling of fullness, okay? So in terms of satiety, so what happens is when we eat fat, right? So here, for example, when the fat or the triglycerides, when they enter the small intestines, we're going to release, what hormone are we going to release? You guys remember? CCK, right? And then CCK is going to be released. And then one of its function is going to stimulate satiety. And this means feeling of fullness. Now, this is short term, right? So what this is going to do, the fat is going to kind of regulate how much food you eat, right? So if you eat like a really super low fat diet or a no fat diet, and you'll probably end up eating more food, and in the long run, you'll have more calories. So that's why when we get into weight loss, which will be next week, we always recommend you have at least 20% of your calories coming from fat. Okay, so we want to make sure there's some fat in order for that satiety signal, so you don't eat as much. Perfect example, if you have baked Lays compared to classic Lays, I mean, you may find yourself studying, eating baked Lays, and next thing you know, you come back to your desk to study more, and they're all gone. Like, who ate my baked Lays? And then you realize you did, right? Because it didn't really make you feel full. We call that mindless eating, and we're going to talk about that. Whereas with the classic Lays, you know, you can only, you got to have more than one, but usually about half a bag. So if you came back to your desk, you probably have a half a bag left because it gives you that more feeling of fullness, right? And we're going to get into all that when we get into energy and weight control. Then also we have another one too, is also we have our adipose tissue. This is our fat tissue. So again, what your fat tissue is going to do, of course, these are your long-term energy stores. Okay. Well, it's going to also release a hormone we have not talked about, but it's going to release a hormone called leptin. And then what that does, it regulates your appetite long-term, or how much you, and what leptin does, again, it's going to send a signal to your brain to eat less. Now, this positive sign here, and that means it stimulates, okay, satiety. So if the more fat you have, usually there's going to be more leptin, and that signals your brain to, hey, eat less. We're good to go. We have all our stores left for the winter or what have you. So start eating less. But the problem with obesity is some people don't recognize the leptin. Their brain receptors don't, and they continue to eat. What is that very similar to that we talked about? A disease where we have the hormone, but the cells are not responding to it. Diabetes, right? So it's going to be very much similar. This is how it's going to be very similar to type 2 diabetes, where there's tons of leptin, but your brain's not responding to the leptin. So with diabetes, initially there's tons of insulin, but again, your cells are not responding to the insulin, right? So very similar concept. All right. So anyway, so that's how fat plays a role in terms of satiety. Okay. So now let's go ahead and talk about triglycerides. Since most of the fat in our body is going to primarily be triglycerides. And as you recall, with a triglycerol, we have that glycerol backbone, and then you have fatty acids, right? We have one fatty acid here. We've got another fatty acid here, another fatty acid there. And of course, here's our glycerol backbone. And of course, so when you consume too much energy, that could either be carbs, protein, even fat. And of course, these are going to all get converted into triglycerides, and you're going to store it. Okay. So in terms of 1 pound of fat is about 3,500 calories. Now that's going to be important when we do assignment number 2. And again, next week, we'll get into that. Okay. So usually 1 pound of fat, again, not usually, but 1 pound of fat, if you put it in a bomb calorimeter and everything, it'll be 3,500 calories, right? So in terms of this pound of fat, this is why we always recommend, for example, a calorie deficit of 500 calories. And what that means, we want you to decrease your amount of food and increase your exercise to where you have a deficit of minus 500 a day, because in a week, there's 3,500 calories, right? So if you take 3,500 divided by 7, that would be 500. So that's going to be the principles of weight management. And again, we'll get into that later on, okay? It's creating that deficit. And that's the rationale. Now, in terms of your fat tissue, so here, for example, during growth, so this is especially during childhood. So what happens is you're going to start, your fat cells are going to start increasing in number. And then as you get older, not only they're going to get an increase in number, but as your calories go up, they're going to increase in size. So when you first notice any weight gain, it's first going to be in excess of those adipocytes. They're getting larger, right? Because so the more calories that you eat, the larger that the cell gets. And then we call that would be called hypertrophy, okay? But then eventually your fat cells, they get to a size where they can't accommodate. It gets full. It can't accommodate any more triglycerides. So it's kind of like this room, right? We get a full capacity. Right? You can't get probably 1,000 students in here if we reach a breaking point. So now we have to increase the number of fat cells. So that's what happens is as you get older and you do exceed your caloric intake, you're going to make new cells. And that's called hyperplasia. So not only are your cells getting bigger, but they're increasing in number, okay? So then you say, okay, you notice the weight gain, so now you go on a diet. Well, what happens is when you do, or not a diet, I shouldn't say diet, because you also have to do activity, physical activity and behavior modification. Well, when you go on a weight loss plan, and what happens is your fat cells, you don't get rid of the fat cells, they stay there forever. But what happens is they shrink. And then what happens is they go and they shrink. So here, for example, this shows you fat loss, right? So of course, so here you are here. And you go on a weight loss plan, and then you get down to this. But you never get back to the starting point, to where before you increased your, before you started making new fat cells. So does everybody see that, right? So like for most people who were, let's say 50, 55, 60, they want to go on weight loss, they want to weigh what they did in high school, which would be like 35 years ago. They'll never reach that point because they've already increased all those fat cells. So you can only decrease it, you reach a threshold. And when we get into weight management again, we'll talk more about that. Okay. All right. So any questions on this here? I usually always get some question about liposuction. Right. So, you know, like liposuction is, go in there and suck all the fat out. So then what it does, it stimulates your fat cells to make more to replace the ones that you just missed. So it kind of defeats the purpose, and that's why it's not successful. Okay. It's more cosmetic anyway. All right, and we're going to get into all that. Okay. All right, so now let's take a look at the biochemistry here. So of course, this is your diet, and we've already talked about in terms of your diet. These are going to be your triglycerides. They get broken down to fatty acids, and then of course they get, once they get to the adipose tissue, they're going to get stored as triglycerides, right? So I know it's been a while, but we saw this a few weeks ago. So here, of course, we have our diet. And remember, these are going to be, these triglycerides are going to be in your chylomicrons, or they're going to be in your VLDL. You kind of remember that? You know, chylomicrons, it transports fat from your diet. And then your VLDL transports fats from your lipid. Right? Now, this is important for you future clinicians because we're going to look at triglyceride levels in the blood, and that's what we're going to be measuring, is that VLDL. Okay. So here's our chylomicrons that contains these triglycerides, or it can be your VLDL, right? Very low density lipoproteins, right? So these are going to be high in triglycerides. And then, of course, we have this here LPL. This is our lipoprotein lipase. Now, this is the same lipase as your pancreatic lipase. So remember your pancreatic lipase, it broke a triglyceride down into 2 fatty acids and a monoglyceride. You guys remember that? Let's see. Okay, you guys remember that? And then you're going to re-esterify it. So now this time, we're talking about lipoprotein, because the chylomicron is a lipoprotein. And we're talking about either VLDL, because it's also lipoprotein. So now we're talking about lipoprotein lipase. So when it breaks down the triglycerides that are in their lipoproteins, it's already in the blood. So that's where we are, right? So of course, and that's when, in this case, we're going to get those 3 fatty acids because of this LPL, the lipoprotein lipase, right? And then we're going to re-esterify it again, and then we're going to store it as triglycerides, okay? Now, what I want to point out on this slide is insulin plays a role in this. So one of the functions of insulin, right, it's going to stimulate you to break down those triglycerides so you can take them up by your fat tissue so you can store them. So what insulin is doing, it's promoting fat storage, right? Does everybody understand? Okay. And it's going to have a significance when we start talking about low carb diets, right? Now, what insulin is going to be doing in this case, it's going to be when you see a sign like this, that means it blocks it, right? Or inhibits it. I mean, some of you may have taken physiology before, and when you do pharmacology, you're going to see these signs all the time. So if you have like a line with a straight line down like this one, then that means it inhibits it or it blocks it. Okay. That's what a lot of your meds are going to do. So in this case, what insulin is doing is blocking the breakdown of your triglycerides, right? Anybody follow? Okay. Now, what stimulates insulin? You guys remember from diabetes? What stimulates the release of insulin from your pancreas? Oh, come on. You guys are going to be like health professionals one day. It has to do with diabetes. Carbohydrates, remember glucose from your diet. So when your blood glucose levels increase, it stimulates your beta cells to release insulin. You guys remember that? Right? So, of course, so here you have high glucose. And the glucose is going to stimulate your beta cells to release insulin. Right? You guys know that, right? Okay. So what is the significance of this, right? So where are we getting this glucose from? Again, I have a point here. Where are we getting the glucose from? Carbs, right? So now taking a look at this picture, if I go on a low carb diet, right? And am I going to be activating lipoprotein lipase? No. So am I going to be able to store fat if I'm on a low carb diet? No, right? So again, on a low carb diet, I won't be able to store fat. And also now this is taken away. So now I'm going to break down more triglycerides. So now I'm going to start breaking down body fat, right? And then will this lead to weight loss? If I'm breaking down body fat? Yeah, and that's the premise of the low carb diets, because with the low carb diets, what it does, it decreases your insulin. And as a result of the decrease in insulin, you're not going to store as much fat. You're going to start breaking more fat down because your insulin levels are low. Okay. Well, again, I know everybody does ketogenic diet, low carb diet. Okay, so this is how that works, right? Okay, so now let's move on. So here, and then speaking of which, so this is what happens. So here, there's no stimulation of insulin. So this is called lipolysis. And then of course, what happens, you're going to break down these triglycerides to release fatty acids. Okay. And then of course, these fatty acids can be used by your muscles and all sorts of things. All right. All right. And then when you do start producing too many fatty acids, and what happens is you overwhelm, this is acetyl-CoA, and you overwhelm the citric acid cycle or the Krebs cycle. So then that's when you're going to start making ketones. Okay, so what the ketones, that's when you break down fat very rapidly. Hence the word ketogenic diet, right? You get, now you follow, right? So low carbs, low insulin, no fat storage, rapid fat breakdown, and then that causes the production of ketones, right? So we're going to come back to that when we get into weight management, okay? So fat plays a role in all of this, okay? All right, so the phospholipid bilayer. Now, this is the final exam question. So, and again, we don't want to produce ketones in healthy people. So this is one of the main functions of carbohydrates is to prevent ketosis, right? You guys remember that? Okay, so one of the functions of carbs is spare protein and also to prevent ketosis, okay? And that's because insulin is going to prevent all this. All right, so phospholipid bilayer, here's another one. So here you have, here's your your bilayer. We've seen this in like every probably biology class. Okay, so of course, here's your fatty acids here, right? So all of these are going to be fatty acids. Okay. And then of course, in that blue there, that's going to be the phosphate, and that's what makes it soluble. Now, this phospholipid bilayer, this is going to be very important when it comes to health, okay? And we're going to talk about this. First of all, in that phospholipid bilayer, of course, we have we have receptors. That's part of the proteins that are embedded. Remember, these are called integral proteins. We also have LDL receptor, which we talked about before, and we have glucose transporters, okay? So all of these, your GLUT4, your LDL receptor, your insulin receptor, all these are proteins, and somehow we need to allow them to fit into the cell membrane, okay? And we're going to come back to that in a second, okay? So ordinarily what happens, here's your LDL cholesterol, right? So what your LDL cholesterol is going to do, it's going to bind to this receptor. Again, it's just located in your phospholipid bilayer, and that's going to take up your cholesterol from your blood. And then, of course, that's when your liver is either going to store it or use it for other things, okay? So here, for example, let's take a look at this. So as you notice, again, all of these are fatty acids, okay? Now, if these fatty acids, if they're saturated fatty acids, they're going to be able to, their structure of the saturated fatty acids, physically speaking, is they're straight. So you're going to be able to pack those in there, right? And if you pack those in there really tight, then it's not going to let one of those proteins like the LDL receptor to fit in the phospholipid membrane, okay? And again, we'll talk a little bit more about this. So you don't want your phospholipid bilayer to be packed really tight because, see, look, your LDL receptor, for example, this is a clinical correlate. Let's say it's here, it doesn't fit, right? There's no place for it. And then what's going to happen is your LDL cholesterol that's going to increase. And I have another slide which makes this more clear, okay? So we prefer this phospholimbrane to have fluidity. So in terms of your body, it prefers polyunsaturated fatty acids, and it prefers monounsaturated because they have a kink in their physical structure. And see now, this is a lot more spacious. Here you can see this little kink here, kink there, and what this is doing is increasing fluidity. And specifically, this is our EPA and our DHA. Remember, these are our omega-3 fatty acids. Okay. So here's an example. So notice here, see how straight this is, relatively speaking. So this here would be all saturated fat that is part of the membrane. So let's say in your diet, you ate a lot of saturated fat. Let's say you ate tons of coconut oil. So now your cell membrane is going to be packed with saturated fat. So that thing is going to be tight. It's not going to be very fluid-like, and it's going to disrupt how much LDL receptor can fit in that membrane. So it's going to decrease their number, right? So we're here, these are our unsaturated fats. And you see how much more space? See all that space? Have a lot more space compared to here. See, no space. Space. And again, that's going to be very important, right? To accommodate that LDL receptor, especially, okay? So again, some of you, you may be thinking about, okay, is there any relationship with the LDL receptor, intrahepatic circulation? I don't know if you remember all of that, okay? So, and then does it have a role? Absolutely, right? So, and then we'll take this slow. And remember, let's go back to the liver and bile. So remember, bile, your liver makes bile, right? So what happens is when you make bile, your gallbladder is going to release it. And then here, you're going to recycle it, right? So 95% of your bile is going to be reabsorbed, right? Now, this is going back to intrahepatic circulation and soluble fiber. So what happens is what we can do is we can consume soluble fiber and it's going to prevent this, right? So now so as a result of preventing that recycling, then our bile is going to start to decrease, right? So now as we decrease that bile, we have to make more bile. And again, we talked about this a million times. We're going to use cholesterol, right? And then, of course, eventually, we're going to need more cholesterol. And then, of course, we're going to get that from our LDL cholesterol. Right? So it's going to come through. It's going to bind to your LDL receptor. And then it's going to release that cholesterol. Right? And then it's going to make more bile, right? So as a consequence, your LDL levels are going to decrease, right? You guys remember this? All right. So you consume soluble fiber. It's going to bind to the bile. So now the liver has to make more bile. So what it's going to do is going to remove cholesterol from the blood to make that new bile. And as a consequence, your LDL cholesterol levels decrease, right? You guys remember all that? Okay. Now we're adding on another piece to that, right? So the other piece is we also have to have LDL receptor. And this LDL receptor, it has to fit into this phospholipid bilayer. Right? So if this phospholipid bilayer, if it was mostly saturated fat, it's going to be hard and there will not be any LDL receptor. So what happens is your LDL cholesterol is going to be much higher. Okay. And I'm going to show you in a second how that works. Okay. So we're going to come back to that. So here, for example, here's your LDL receptor. So here's your membrane that has mostly saturated fatty acids, right? See how straight those are? So now what happens is, see, this LDL receptor, it can't fit. So since it can't fit, your LDL cannot bind to that receptor. Does everybody see that? The LDL stays in the blood, so you're separating it, right? So let's say if you, I don't know, it's kind of like you keep someone out of the room. Let's say there's someone in here. Let's say you had to do a project or something, right? And there's two of you. But if I lock that door and then your partner is on the other side and you're in here, are you going to be able to work together? No, because I locked the door. You can't get in there, right? But then if I open the door, then your partner can come in and then boom, you can do your project. So in this case, what's happening is this here, because this is so rigid, it's keeping that door closed for the LDL cholesterol. So the LDL cholesterol, there's no way for it to be removed from the blood. So it stays higher in your blood. Okay? Does everybody follow? Okay? Now with unsaturated fats, what's going to happen? You're going to have that spacing. So here, now, yes, now finally we have contact. So bam, it's going to bind, and then now that's going to go in, and now your LDL levels in your blood are going to decrease. Whereas here, see, it never reaches up here on the cell surface. So here, you're going to have an increase in blood cholesterol. Okay. So this is why, you remember when we talked about dietary fats? You remember with you remember the unsaturated fats in terms of mortality? Which type decreases mortality? It decreases more, it means you die earlier. Saturated fat, polyunsaturated fat, saturated fat, right? So when we looked at that graph, which one actually increased your longevity, allowed you to live longer? It's going to be this one. And this is why. It's because those polyunsaturated fats makes the membrane more fluid. So your LDL levels, your LDL receptor can fit into the cell membrane, and then it can remove more blood cholesterol. So it's kind of like, think of it like this. Think about what if you type 2 diabetes. I think all of you understand type 2 diabetes, right? So in order for your cells to take up glucose, you have to have an insulin receptor, right? And it's in the cell membrane. But then what if I remove the insulin receptor? You're not going to have a signal to take up glucose. So here, essentially, you're not removing it, but it just can't get into the membrane. So it's not available. So your LDL cholesterol is going to. Okay. Now let's go back to this slide here, because when you guys start making recommendations, right here, right? So let me ask you this question: soluble fiber is going to decrease our blood cholesterol, will it? Sure. And this is how it does it right here, right? And then also, if I decrease saturated fat in my diet, is it going to decrease my LDL cholesterol? Yeah, and that works right here. So now, if you want to lower your bad cholesterol levels, you want to decrease saturated fat, eat more fiber, right? So anyway, so this is the physiology behind those recommendations. Okay. Okay, our biochemistry, one of those. Okay. Okay, so the next one, this is easy. This is more in foods, emulsification, phospholipids. It is found in a lot of food, in terms of, especially like with salad dressings. You may have noticed, here, for example, you have your water, it's incompatible with oil. So then you have an emulsifier in there and it allows it to mix. I'm not going to ask anything about this other than bile. Okay. All right, myelin sheath. Yes, it's also very important. Your fat is very important for myelin. Okay. So when you look at this healthy nerve, what you have here is you have your myelin, right? So what your myelin does, it serves as an insulator. It's going to insulate your nerves. Okay. And of course, it's going to be very important because your nerves, basically what it does, your nerves really transmit electricity. Like you got all kinds of electric circuits in your body. You probably have more electrical circuits in your body than a computer does, right? And then so when we have an action potential for nerve transmissions, that's all those electrons that are firing, right? So of course we need to insulate it so it can travel fast enough, and also so you don't feel that electricity in terms of your tissues, right? So what happens with if you don't have enough fat, or in that case, if you have a decrease in fatty acids, okay, or if you have a decrease in vitamin B12, and what happens is here you can get a demyelination. And now the problem that's going to cause is now you have a short circuit in your body, and then also it's going to be very painful because you're going to feel those sparks. It sounds just like that, right? So now if you think about it, when I look at this, I always think of wires. See these wires here? See how I'm touching them? See, it's no problem, right? So anyway, all these are insulated, so I can touch them, but there's all kinds of electricity going through there. Now, if there wasn't, and if I touched one, right, I'll have some problems. So this is why this is very similar to a multiple sclerosis, MS. I don't know if you know this, and it's very painful. And also, this is due to a vitamin B12 deficiency, and we call this pernicious anemia because it means painful death. So you die from the nerves, and you also die from, when we get into B vitamins, we're going to talk a lot more about this, from the anemia, okay? So fat's important. Also steroids. So here, in terms of cholesterol, for example, we're going to need it for our sex hormone steroids. So we're going to need that for reproduction. Estradiol, that's testosterone. And then of course, estrogen will be as part of this as well. So again, we need this for reproduction, okay? And then also glucocorticosteroids, cortisol, we're going to need that, especially when our blood glucose levels get super low or in response to stress. So you've heard of fight or flight. So that's when your cortisol levels, it's your stress one, it's going to increase big time to provide a lot of glucose for your muscles so you can get the heck out of there. So if you're on your scooter and you cross a bus and a bus is about to hit you, your cortisol level is going to go, and then that's going to release that energy so you can, no, you don't really scoot, do you? You can put more of the accelerator on the pedal or jump off of it, get out of the way or whatever. And we're going to come back to cortisol because one of the functions of cortisol is it does stimulate your appetite. And when we get into obesity, we'll talk about how people who have a lot of stress, and half of those people who have stress, their cortisol levels are going to be really high, emotional stress. Cortisol levels are going to be high, and they're going to end up eating more for it because of the stress. Okay. And we'll talk more about that later on. We'll come back to that. Now, when we get into, if you take nutrition and disease, when you go admit into the hospital, this is called a stress hormone. So it's going to increase during hospitalization. That's to cortisol will. And cortisol levels increase during illness and also during trauma because you need that glucose in order to survive. Okay. And we'll get more into that later. All right, eicosanoids. These are also going to be important. These are hormone-like substances. Okay. So here, for example, we get, these are derived from our omega-3 fatty acids. So for example, we get this from fish oils, these fatty acids, omega-3s, and our fatty fish. And then one thing that they do is they do increase the fluidity. We already talked about that. So EPA, DHA, again, these are omega-3 fatty acids. And we already know that the benefits of these, number one, is that these omega-3s, they increase the fluidity of the membrane. It allows more LDL receptors to fit so you can remove more cholesterol from the blood, right? We just talked about that. Well, they're also going to be very important for the synthesis of these eicosanoids. So here, what happens is these fatty acids, they're going to be clipped and they're going to be released. So there they are. But now they're being clipped from the membrane. So they're going to be released from the membrane. And when they're released from the membrane, they're going to be used to make prostaglandins and prostacyclins. Okay. And of course, these are eicosanoids. And then what they're going to do is one thing is called thrombocyte aggregation. So what it is, it's going to make your cells less sticky, your blood cells less sticky. And of course, that's going to decrease blood clots. Okay. And then they're also going to help decrease inflammation and lower your blood pressure. Okay. So again, this is more reason why you want to make sure you consume a lot of polyunsaturated fats in your diet, because the polyunsaturated fats in your diet, the omega-3s, we already talked about it, helps lower your blood cholesterol levels, but they are also going to help decrease inflammation related to heart disease, and they're going to decrease blood clots. And we'll put all that together on Wednesday, right? So a blood clot, are they good? A blood clot floating around? No, because they can go to a microvessel in your brain, you have a stroke. To your heart, then it can cause a heart attack. Or you can go to your lungs, called an embolism, and then you'll die like that. So no, these are not good. So polyunsaturated fatty acids help you keep your blood thin. They work like a blood thinner. They were very similar to a blood thinner. So relative to heart disease, so they're doing three things. They're going to be help reducing the inflammation. They're going to help decrease the blood clots, and they're definitely going to help decrease your blood cholesterol levels. And that's why we always recommend fatty fish, right? And nuts. Okay, so and then there we go. See, prevention of cardiovascular disease. So now you know one. All right, so let's go ahead and introduce this, and then we will be done in a second. So anyway, cardiovascular disease. So that's where we're transitioning into. So I'm going to give you an overview of cardiovascular disease, but also we're going to tie that to your diet, okay, especially relative to fats. And we've kind of already talked about a little bit about it, okay? And we're going to get into the heart healthy diet. All right, so first of all, when we talk about cardiovascular disease, we're not just talking about heart disease, right? And we always abbreviate this CVD. So anyway, we can have heart failure. So that's when, like, congestive heart failure. And nutrition really doesn't play a big role in congestive heart failure. I mean, it does once you develop it, but in terms of preventing it, not really, okay? And then arrhythmias. So when you think of the heart, for example, you need to think of two things: electricity and plumbing, right? So when it comes to heart disease, specifically, you're either going to have a problem with the electricity or you're going to have a problem with the plumbing. So an arrhythmia is when you have a problem with the electricity, and this may require a pacemaker, for example. And then when you have a problem with the plumbing, then you're talking about the blood vessels can get clogged, just like you have a pipe that's clogged, right? So, okay. Now, in terms of, so that would be the arrhythmia. Now, arrhythmias, these are usually caused by an electrolyte imbalance. So if you, or they can be, okay? And arrhythmia just means an irregular heartbeat. And it can either go like 135, 150 beats per minute. And then, so one is the rate, and then the other one is called the rhythm. So with arrhythmias, it can go, it should go, I mean, with your heart sounds, it should go lub dub, lub dub, lub dub, lub dub. But then when you have an arrhythmia, it can go lub dub, lub dub, lub dub, lub dub, lub dub. So I mean, so that would be called, it's called AFib. Some of you may have seen the commercials. So anyway, there's a million reasons, right? So that would be an arrhythmia. Usually this is called due to electrolytes. Now, arteriosclerosis, this is where it's going to be mostly tied to nutrition and prevention, right? So lifestyle. So with coronary artery disease, and what we're talking about here is we're talking about the plumbing. So that's what we're talking about, okay? And then also and of course with the arrhythmia, we're talking about the electricity. So with coronary artery disease, we have the coronary heart. And then of course, this is what can lead to a heart attack and sudden death, right? And then we also have carotid artery disease. This is right here. And then this is what can lead to a stroke. So if you've ever been around a cardiologist, oftentimes they'll check out your carotid artery. They may even listen to it. And then because if you have a blockage of your carotid artery, then it's going to prevent the blood flow going to your brain. And it can cause a stroke, right? And then of course, cerebrovascular, cerebro meaning, and then of course that would be ischemic stroke and hemorrhagic stroke. Ischemic stroke is a blockage and there's dead tissue of your brain. Whereas hemorrhagic stroke, that's where a blood vessel has bursted and now their blood is all over, it infiltrates all your tissues. Hemorrhagic stroke, those are the worst. Survival rates are very poor with hemorrhagic. And then ischemic strokes, that's mostly due to a blockage. And of course, so with coronary artery disease, as well as cerebrovascular disease, fats play a key role in all that in lifestyle. And we'll talk about that on Wednesday.